Hello, this is Wafer Agent. Today we explore two quality parameters that are completely invisible, yet they can silently destroy semiconductor performance: nanotopography and metal contamination. Let's find out what they are, how they're measured, and why they matter so much in chip manufacturing. Nanotopography refers to subtle height variations on the wafer surface in the nanometer range, occurring over a millimeter scale lateral distance. It sits between flatness, which covers long-range bow, and roughness, which covers very short-range surface texture. Why does this matter? During CMP, chemical mechanical polishing, the polishing pad presses against the wafer surface. If the surface has nanotopography, the higher areas get polished more, and the lower areas get polished less. This creates uneven film thickness across the wafer, which can lead to device failure. As device geometries shrink, nanotopography has become an increasingly critical quality parameter. Nanotopography is generally measured using optical interferometry. A light beam is projected onto the wafer surface. The reflected interference pattern is analyzed to generate a precise height map with nanometer resolution. Spatial frequency filtering is then applied to separate nanotopography from flatness and roughness components. The result is a full wafer nanotopography map showing height variations across the surface. Optical interferometry-based surface profilers are commonly used for this measurement. Specific equipment specifications vary by manufacturer. Metal contamination refers to trace amounts of metallic elements, such as iron, copper, sodium, and nickel, present on or within the wafer. Even at concentrations of atoms per square centimeter, these metals can create energy trap levels inside the silicon bandgap. This increases leakage current, degrades gate oxide integrity, and reduces minority carrier lifetime, all of which lower device reliability and yield. Copper is particularly dangerous because it diffuses rapidly through silicon at elevated temperatures. Metal contamination is generally analyzed using ICP-MS, inductively coupled plasma mass spectrometry. The wafer surface is dissolved in ultra-pure acid, concentrated, and analyzed at the parts per trillion level. This is one of the most sensitive analytical techniques used in the semiconductor industry. In summary, nanotopography is a nanometer-scale surface height variation in the millimeter range. It causes CMP non-uniformity and is measured by optical interferometry. Metal contamination, even at trace levels, alters device electrical characteristics. Iron, copper, sodium, and nickel are the key concerns. It is measured by ICP-MS at parts per trillion sensitivity. Both parameters are invisible, but both are critical to whether a chip performs reliably. In the next episode, we'll go deeper inside the wafer, exploring oxygen, carbon, and BMD. Thank you.